So after quadrilateral, we'll start with polygons. What is a polygon? As the name says, poly means many. It will have many sides to it. Quadrilateral means 4. 5, if it has 5 sides, it will be called as pentagon. If it has 6 sides, it will be called as hexagon. 7 sides, it will be called as heptagon. 8 sides, it will be called as octagon. And 9 sides, it will be called as nonagon. And 10 sides, it will be called as decagon. Okay, so these are all your polygons. We'll only talk about regular polygons here, okay, and we'll take an example to understand this formula. What are regular polygon? All sides and all angles are equal. So in a regular polygon, all sides and all angles are equal. Remember that. Now to understand this formula, exterior angle of any regular polygon is given by 360 divided by n, where n is the number of sides. Let's take an hexagon. N will be 6 here now. So exterior angle will be what? 60 degrees. Okay. Similarly, interior angle is 180 degree minus exterior. So 180 minus 60 is what? 120. You can do this with any polygon, any regular polygon. Okay. As we know, for a regular polygon, all the angles will be equal. So all the angles are equal to 120. All the interior angles. And all the sides will be equal to A. Sum of all the interior angles of any polygon is given as n minus 2 into 180 degree, where n is the number of sides. So in this case, 6 minus 2, 4 into 180, 720. Yes, add all the 120, that will be 720. So remember this formula about polygons. You can apply this to any of the polygons. Now let's take a problem on polygons. What fraction of the area of a regular hexagon is the area of a regular hexagon obtained by joining the midpoints of the sides of the first hexagon? So I draw an hexagon, I take its midpoint, I take midpoint of all the sides, and I draw one more hexagon with this midpoints. I draw one more hexagon at the midpoints, and I am being asked what fraction area of a regular hexagon is the area of hexagon obtained by joining the midpoints, which means smaller hexagon is what part of the bigger hexagon. That is what I want to know. So I know the area of bigger hexagon will always be bigger than the smaller ones, but it is what smaller hexagon is what part of the bigger hexagon. Okay, that is the question. So let one side of a bigger hexagon, which is in yellow, be 2a. Since there is a midpoint, it will be split into a into a. Now let's just drop a perpendicular from here. As we know, exterior angle is what? We just did it is 60, right? 360 divided by n, where n is the number of sides. 360 divided by 6, exterior angle is 60. So the interior will be 120. Interior will be 120, which we got it in the earlier example as well. As a is equals to a, this forms an isosceles triangle. So that will be 30, 30, because sum of the measure is 180. So this forms a 30, 60, 90. We've done such problem earlier. Side opposite to 90 is a. So side opposite to 30 will be half of that, a by 2. And the side opposite to 60 will be root 3 multiplied by a by 2. So root 3a by 2, root 3a by 2. If I add both of them, then the side of a smaller hexagon, which is in red, comes out to be a root 3. And that is the side of my smaller hexagon. Now I need to find its area and compare its area with the bigger yellow hexagon. Now let's just draw it diagonals. By observation, we can see this regular hexagon is formed by 6 equilateral triangles. Yes, 6 equilateral triangles form this one regular hexagon. Let's count 1, 2, 3, 4, 5, 6. These are the 6 equilateral triangles. Now what is an area of an equilateral triangle? We studied this in triangle. What is the area of an equilateral triangle? Which is square root of 3 by 4. Square root of 3 by 4 into side square. And what is the side of this equilateral triangle? It will be a root 3. Check it there. Red side is a root 3. So this is square root of 3 by 4 into 3a square. That is now the area of one equilateral triangle. But 6 such equilateral triangle form my hexagon. So multiply this area by 6 to get an area of hexagon. I don't want the area of equilateral, I want the area of hexagon. So 6 into this is the area of hexagon. Now cut this. 2 2s are 2, 3s are, what do I get finally? 3 into 3 is 9, 9 root 3. And what I have, root 3a square upon 2, right? 9 root 3a square upon 2, that is the area of the smaller hexagon. Let's find the area of the bigger hexagon as well. Square root of 3 by 4 into side square will be the area of one equilateral triangle in that. So 2a square is 4a square, but this is area of one equilateral triangle multiplied by 6 to get the area of a bigger hexagon. Now divide the two areas. Divide the two area to get the fraction. So if I divide, I cut most of the things here. A square is square 4, square root of 3, and what am I left with? 3, 2 3s are 6, and then what? 3 2s are 6, 3 3s are 9. So what am I left with? 4 by 3. What is this 4 by 3? What is this 4 by 3? Area of larger as compared to smaller. Okay, I need smaller hexagon as a part of bigger. So smaller hexagon as a part of bigger will always be what? 3/4. It will be less than 1, right? So it will be 3/4 of the bigger hexagon. That is my answer to this question. 3/4. Okay, the fraction is 3/4. Smaller is 3/4 of the bigger hexagon, and that's how we solve the problem.